I'm going to be using all this equipment to explain relays to you guys. So a relay, in essence, operates kind of like a light switch. You energize a relay and it tells things to turn on. It moves power from one point to another when you energize a relay coil. Why do we need relays? Here's a good example. So this right here is an Arduino Uno. It's a little microcontroller, and you can turn on an output from an Arduino Uno to turn things on. So maybe we'll turn on output 1 on the Arduino, and we'll turn on this little motor right here, and the motor will spin. But what if we want to use that Arduino to turn on this motor? I don't think I'd feel comfortable running the power necessary to operate this motor through this tiny little Arduino. So we turn on a relay, which uses a very small amount of current or power, and then the contacts in that relay turn on this motor. So that is one main reason why we need a relay, is it protects our controlling devices so we don't have to run high current through them. As I said, you can think of a relay kind of like a light switch. You can see here, terminal 13 and 14 is the coil of the relay. And the coil of the relay, it's a magnet inside of the relay that energizes. You can see in that top right corner, those contacts either come together or move apart when you change the state of that relay. Again, it's just a little electromagnet that moves a lever up and down that changes the state of contacts. You can see this particular relay, the coil is energized at 120 volts AC through terminals 13 and 14, and it operates at 7 amps. So you can run 7 amps of power through these sets of contacts. All right, so if you're looking at wiring schematics, this is how you denote turning a relay on. That's the coil. And then later in your schematics, you'll have something like this. And that just denotes the contacts of the relay turns on something like, I don't know, let's say a motor. So you flip on the light switch, energize the coil in the relay, the contacts change state, and this is a normally open contact. So just like a light switch, when you energize relay 1, current will travel, voltage and current will travel through this set of contacts and turn on the motor. So yeah, let's start with that, and I can demonstrate that. So I'm going to turn on relay 1, and then we're going to use the power going through relay 1, a set of normally open contacts, to energize a motor. Let's start with that. So this is a circuit breaker. We're going to use that for protection. Here's my relay, and down here is terminal 13 and 14. It says right on there A1, A2, and A1, A2 is always the coil to your relay, so I know that's where I'm putting the power. And I need something to tell this relay coil when to turn on and off. So for right now, we're going to use a push button, and I'm going to find the normally open contacts on the push button. So when it's not pushed, we want to open circuit so we can measure resistance. You always turn off the power, then measure resistance. It's open, and we're measuring ohms. We push the button in, and you can see that set of contacts closes because there's very low resistance when I have the button pushed in. So that's what we're going to use. I'm going to wire up between these two contacts. So I'm going to run the power to right here. We're going to go through the push button, and then I'm going to go to A1 on the relay to energize the coil when I push the button. On this relay, and find a set of normally open contacts. Now look at these little switches. Look at 9 and 5. Notice how they are not connected. The normally closed set would be 9 to 1, meaning when the coil is not energized, 9 and 1 are connected. Then when we energize the coil, that little diagonal line is going to switch states, energizing terminal 9 to terminal 5. So I'm going to run power for my motor. It's going to go to terminal 9, then go out terminal 5 to my motor. Here's something that's not well known. If you're having a relay that is supposed to be energizing and it's not, you can check the voltage going to the coil. See if you have 120 volts. Say you have 120 volts and it's still not turning on. What you want to do is check the neutral side. Check your A2. If you still have 120 volts on the incoming and the outgoing of the coil, that means your circuit is interrupted and your path back to neutral is not complete. Relay contacts can become corroded. You can have voltage drop through the relay contacts. And here's where, just being a technician, taking your time and using your multimeter comes in handy. I believe this relay is considered a quadruple pole, meaning there's 4 separate sets of contacts. Quadruple pole double throw, because you can throw it to one circuit or another one. If it was a single throw, it would either send it to one circuit or it would just not do anything and open up the circuit. But because it's either going to line A or line B, it's double throw. If that's wrong, correct me in the comments, and I don't know, I can't really do anything, but I'll pin it at the top if I'm wrong. So I'm plugging it in now. This is a little sketchy. This is definitely a pretty cheap motor. I think I paid $20 for it. I'll put a link in the comments. Made a combined total of $18 off my Amazon affiliates program, which I've been a member of for like a year. Okay, I'm pushing the button. Woo, look at that. All right, so we turn on the button. So we're flicking the light switch, which is the coil, and then the actual circuit energizes because it's a normally open circuit. And we're cooking with butter. Let's go. All right, so now that we've done that, I think I'm going to kind of rewrite the circuit and make it a little bit more complicated. And I'm going to introduce this guy. We're not going to use it, but I'm going to talk about it. This is a contactor that is non-reversing. It can either go forward or back, and it only goes one way at a time. So what you can do to run something like this is you can have a relay that either sends an output to this coil on this one, on the normally open circuit, or on the normally closed circuit. You can energize this coil. And that's pretty much what we're going to do. But we're not going to use a contactor. We don't need to use a contactor. Contactor is used. You can see there's 3 phases. You use it for 3-phase motors. The cool thing about a contactor, why you would use it above a relay, obviously, is the 3 phases. And also you can allow more power to run through it. It's built for energizing motors over and over again. We're just using relays and single phase AC for this demo. But I'm going to turn off my power so I'm safe. If you look at this motor, there's actually 3 terminals. This is neutral, this is hot, and this is the other hot. We can actually run this motor forwards or backwards. So what I'm going to do is run another wire right here, and we're going to wire in a switch that's either going to choose forwards or backwards. We're going to have a forwards or backwards switch. We're going to make our selection, and we're going to use the same set of contacts on a relay. The normally open set will go here. So if that relay is energized, we will go forwards. Or if that directional relay is open, if that directional relay is turned off, we're going to run through the normally closed contacts to right here. So we're still going to start the same way. So we're going to have our push button, our normally open black push button right here. And when we push that button in, we're going to run the motors. So we'll run that to a relay. And and we'll call it power relay. So the difference now is we're going to introduce another relay. And we're not going to put a push button, we're going to put a toggle switch on that relay. Directional relay. And then it's not super complicated. So now we're going to want our power. Let's draw the schematic to run the motor forward. So I'll call that M, and I'll put an F here. To run the motor forward, to energize that one terminal on this side. This is this. Boom. We want our power relay to be on, obviously. So we're going to call that relay power. And when we push it in, we want it on. On is good. On is happy. So when it's not on, normal state, out of the box, it's off. So we're going to call that a normally open. Normally open means out of the box, holding it in your hand, the set of contacts that we're going to use on our power relay. If our power relay is not energized, then this is an open circuit. See that? That's the normal state. It's open. It's not touching. And then, obviously, when we energize the power relay, we're going to pass through like that. And then our directional relay, let's do the same thing. Only if our directional relay is energized do we want it to run forward. And then for our motor to run backwards, which is not installed yet, but I'm going to run another 120 wire to right here. So that's our motor backwards wire. We still want our power relay to be turned on, normally open. So we're going to use that same thing. So instead of drawing a whole nother circuit, we can just draw like this. We can tap off of there just like that. And then we'll go over here, and we want the opposite state of our directional relay. So that'll be the normally closed. You can see normally closed. Out of the box, you can see there's still power passing through it. See how that works? So normally closed means, so if our directional relay is turned off and our power relay is energized, then we will run power right here. And then if we energize our directional relay immediately, this will turn off and this will turn on, and it will go the other way. And then whenever we release our push button for our power relay, the whole system will shut down. So I'm going to wire that up for you guys. This is, pretty common stuff. In practice, the circuit would be a little bit more complicated. You would have a seal-in circuit, but I'm not going to cover that in this video just because it's too many different topics. But I have a very popular video. It's called Motor Controls Basics. I implore you to watch that if you really want to get the full picture of how we operate motors out in the field. All right, so we got L1 going directly to the push button. L1 goes directly to the push button. And the output of the push button goes directly to the power relay. Aha. Okay, we're going to need to change that. I'm going to grab another relay. All right, so we're going to use this as our power relay. Guys, I have so much stuff electronics-wise, you wouldn't believe it. I haven't really got a chance to use any of it. Just because I'm busy, man. I've been working about 60 hours a week, most weeks, making so much money. But between, that and then raising my son, obviously a lot of my free time goes to hanging out with him when I'm not working. I don't sleep that much. It's been a lot going on. It's great. I mean, I'm super grateful for what I got, but it's a lot. Anywho, okay, so there's that. We got the output of our push button going to the power relay hot, and then we're going to run the other side power relay to neutral. So I'm just going to steal that neutral from the other one. And then that runs back to neutral right here. Then also coming from L1, we need to go through a toggle switch. And then we need to energize our directional relay. We're going to pretend like this is a toggle switch. I mean, it kind of is. It's an on-off switch. But it does the trick. We're either turning this guy on or off. We're interrupting power. It does the same exact thing. That switch is going back to the A1 on the relay we were using before to energize the coil. A1, A1, I believe it's 13. Oh, this one says 13. This one says 14, whatever. Those are the relay terminals. This is A2, A2, and that's neutral, which is tied to ground. All right, so I need to run A2 back to neutral. This one's only a double pull, double throw. By the way, the diagram on this one looks like this. Looks like normally closed. Then here's your normally open 12 and 8. So I'm going to wire the output of this from 8 to the common on relay directional. So this is 0.8 on the power relay, and this is our directional relay. So we're going to run 0.8 to 9. Call that the common. Not to be confused with like when they call it neutral common. It's just the common on this contact here. So that 9 is normally closed with 1 or normally open with 5. That little diagonal thing is going to go back and forth. So those are going to be our two options. So once we energize our power relay, we're going to get power at 9. Then depending on which direction our switch is set to, we're either going to send power down terminal 1 or terminal 5. Always pay attention to the load that you're running, aka how much current you're going to be running through the wires, because that's always your limiting factor. Current is proportional to power. It's not the same thing, but think of more power, more current, and then current can generate heat. And for this application, relays are a good solution to do what we want to do, which is run this motor with this random ass fan on it backwards and forwards. Sorry, boys, this is got really messy. I apologize. There we go. And girl, I'm sure there's at least one. Boys and girl. Open set. So we're going to be looking for the set that is like this. That's 5. And this is the normally closed set, which is 1. And C normally open. All right, so start with that. All right, boys and girls. I don't think it's going to explode, but I wouldn't be surprised if something did. All right. Now, this is not me acting. I'm being real about this. All right. I didn't hear anything catch on fire. We're going to push the button and see what happens. It looks like we are spinning counterclockwise. And now we're spinning clockwise. See, there's quite a bigger indicator on my one relay. Here, let's turn the lights down. Set the mood, boys. Oh, yeah. Isn't that a beautiful thing? Clockwise operation. I don't know if y'all can see it. Oh. Wise. I'm freaking out, man. Yep. What happens if we do this? Woo! It's a hot flip. We did it, boys. There you have it. I really want to thank you guys from the bottom of my heart for watching my videos. This channel is my retirement plan. I'm making like $2 or $3 a day off of it, and I couldn't be more ecstatic and grateful. It's a fun hobby. I love making videos when I have the time. Find me on LinkedIn if you have any questions. I am an electrical maintenance technician. I specialize in automation, controls, and instrumentation. It's a really good career that you only need a 2-year degree to get started, and it pays better than most bachelor's degrees. So if you're interested, check out my channel, hit me up on LinkedIn. I appreciate you guys. Hope all is well, and take care.